A water-fueled car is an automobile that hypothetically derives its energy directly from water. Water-fueled cars have been the subject of numerous international patents, newspaper and popular science magazine articles, local television news coverage, and websites. The claims for these devices have been found to be pseudoscience, and some were found to be tied to investment frauds. These vehicles may be claimed to produce fuel from water on board with no other energy input, or may be a hybrid claiming to derive some of its energy from water in addition to a conventional source, such as gasoline. Marcani, from the state of Madhya Pradesh, said, "The car runs on acetylene gas, which is formed from a chemical reaction between calcium carbide and water." The water fuel cell purportedly split water into its component elements, hydrogen and oxygen. The hydrogen gas was then burned to generate energy, a process that reconstituted the water molecules. According to Meyer, the device required less energy to perform electrolysis than the minimum energy requirement predicted or measured by conventional science. Casami's modified Peugeot 405 sedan normally runs on compressed natural gas and gasoline. However, in the video, he demonstrates filling the fuel tank with distilled water and potassium hydroxide to generate hydrogen through electrolysis. According to Casami, the car's engine then utilizes the hydrogen gas to generate energy, producing only water vapor as a byproduct. He claims a liter of water can produce 96 megajoules of energy in this system, compared to only 29 megajoules from a liter of gasoline. The Toyota water engine is not a literal engine that runs solely on water, rather, it involves a sophisticated process known as hydrogen fuel cell technology. Water, in this case, serves as a source of hydrogen, which is a key component in powering fuel cells. The process involves electrolysis, where water molecules are split into hydrogen and oxygen using an electric current. 1. Electrolysis. Water, H2O, is subjected to electrolysis, a process where an electric current is passed through the water to separate it into hydrogen, H2, and oxygen, O2. 2. Hydrogen fuel cell. The separated hydrogen is then fed into a fuel cell within the vehicle. In the fuel cell, hydrogen reacts with oxygen from the air, producing electricity, water vapor, and heat as byproducts. 3. Electric power for propulsion. The generated electricity is used to power an electric motor, which drives the vehicle's wheels. This electric propulsion eliminates the need for traditional internal combustion engines, resulting in zero tailpipe emissions. In a petrol car, you replace petrol with hydrogen, which is obtained by electrolysis of water using electric power from the battery. In an electric car, you use electric power from the battery to extract hydrogen from water through electrolysis. Hydrogen is then used to recover part of the electricity with a fuel cell. Electricity is then used to run the electric motors. It is obvious that the conversion of electricity to hydrogen and then back to electricity doesn't make much sense. Using electrolysis, you can break the water molecule H2O into hydrogen and oxygen. Obviously, apart from water, you also need an electrical current which must be supplied by a battery. Energy required for electrolysis. The electrolysis of water to produce hydrogen involves splitting water, H2O, into hydrogen, H2, and oxygen, O2. The theoretical minimum energy required is about 39.4 kilowatt-hours per kilogram of hydrogen under ideal conditions. Efficiency of the electrolyzer. In practice, electrolyzers are not 100% efficient. Modern electrolyzers usually have efficiencies between 65% and 80%. So, to account for inefficiencies, you multiply the theoretical energy requirement by the inverse of the efficiency. However, a common approximation is that you need about 50 to 55 kilowatt-hours of electricity to produce 1 kilogram of hydrogen. Energy content of hydrogen. Hydrogen has a high energy content by weight, with a lower heating value of approximately 33.33 kilowatt-hours per kilogram. Efficiency of an internal combustion engine. The efficiency of a hydrogen-powered internal combustion engine can vary, but it is usually between 20% and 30%. Energy delivered by the engine equals energy content of hydrogen times efficiency of the engine. Using a typical efficiency range. Energy delivered equals 6.67 to 10 kilowatt-hours. We can obtain 1 kilogram of hydrogen from water by means of electrolysis consuming 50 kilowatt-hours of electricity. By burning this hydrogen in an internal combustion engine, we obtain 10 kilowatt-hours of actual mechanical energy in the car. Therefore, with 50 kilowatt-hours of electrical energy we have obtained 10 kilowatt-hours of actual mechanical energy. This gives us an efficiency of only 20%. An electric car has an efficiency above 85%. This means 4 times as much as the water engine. Let us compare some of the existing car power alternatives. A typical petrol car may consume 6 liters of gasoline to make 100 kilometers. Its tank capacity of 50 liters is enough for 833 kilometers. An electric car typically consumes 15 kilowatt-hours to make 100 kilometers. Its battery capacity can be as high as 100 kilowatt-hours, enough for 667 kilometers. A hydrogen-powered car consumes 0.76 kilograms of hydrogen to make 100 kilometers. Its tank capacity of 5.6 kilograms can do 502 kilometers. The water car described above consumes 60 kilowatt-hours from the battery and 10.8 liters of water to make 100 kilometers. Its battery capacity of 100 kilowatt-hours and 18 liters of water can do 167 kilometers. These are some conclusions. The so-called water engine doesn't run on water but on electricity. The water engine is, therefore, a very poor performance electric engine. The efficiency of this water engine is 25% of normal electric engines. It, therefore, requires to carry batteries 4 times larger than an electric car.